Hello, welcome to Virtual Mechanics. We're now going to diagnose a fault on an Audi A3 which has come in with a report of no communication to any control unit on the vehicle. On this vehicle that includes the engine management, the ABS, the airbag, the instrument cluster and the central locker. So I've removed the steering column panel, taken the socket or the diagnostic socket out of its holder. We're now going to check the vehicle electrics to the diagnostic socket. There's our 16-pin diagnostic connector. We've got pin 1, pin 8, pin 9 and pin 16. The important ones for this test are pin 4, chassis ground, pin 5, signal ground, pin 7, our K-wire or diagnostic line, and pin 16, which is the socket power supply. Now, when testing any pins on any connector, I never front probe the pins, and the reason for this is you can damage the pins with your probe, or you can spread them to the point where they'll no longer make good connection when they're reconnected. So we're going to back probe. The first pin we want to check is pin 16, which is our socket power supply. So we'll connect our voltmeter to a known good earth. We'll switch the meter to DC volts. We'll then probe pin 16. We can see there we've got a healthy reading of 12 volts, which is battery voltage, which is fine. We'll then test pin 7, our K line, and on this we really want to see about 3.5 volts. Well, on the meter there we got 0 volts, so that's obviously a fault. That'll be causing our no communication. The next pins to test are pins 4 and pins 5, our 2 earth lines. So for that we need to switch our meter to resistance. We also need to disconnect the vehicle battery, as you can't do any resistance checks on a live circuit. The voltage the meter uses to carry out the resistance test will actually damage any control unit circuitry. We've disconnected the vehicle battery. We're now going to set our meter up to measure resistance. The first thing we're going to do is touch our probes together and turn the meter to resistance. And this is just to do a meter test and lead test. Make sure everything's working fine. We'll put our earth probe back onto earth, and we're going to go back onto the back of pin 4, and we've got a reading there of 0.4, which is 400 milliohms, which is a near perfect earth. We'll do the same test for pin 5. And that was showing 0.6, 0.7, that's 600 or 700 milliohms. That's again a near perfect earth. I'm also going to carry out a resistance test on pin 7, considering we had no voltage on that pin at all. We want to make sure we haven't got a short. So the reading there is 1.3, 1.4 ohms. So that's obviously our issue. We've got a short to ground somewhere on our K line. Most probable causes for that would be any of the control units are internally damaged and we're putting that wire to ground. We could have water causing rot on the cables or causing a short. Or another common issue is on VAG group vehicles, the diagnostic line goes straight to any audio equipment, the stereo. So any aftermarket stereo fitted could interfere with that diagnostic line and could be giving us either a situation where you'll find 12 volts on the line, which would blow your kit, or it will put that wire to ground and we'll have no communication. I'm now going to disconnect each control unit one by one, checking in between the resistance to our diagnostic line, see if it improves on disconnecting any of the equipment. I checked through all the control units and we found the fault. There was damage to the K line between the instrument cluster and the stereo. We've made good that wiring, reconnected the vehicle battery, and I'm now going to retest pin 7 at the plug. I'm going to probe pin 7, switch the meter to DC volts, and we've now got a reading of just under 4 volts, which means our diagnostic socket's now healthy and it's safe to connect any equipment.